Good afternoon, everybody. My name is Lee Washburn. I'm the Director of Gas Electronics for Sentience. My background is in the design and development of control electronics for heating appliances. Most recently, I've been involved in the gas sensing program, which is what I'm here to talk about today. What I'll briefly do is give you a quick overview of the company, a little bit of information about the market, kind of situation as to why we need gas sensors, our own roadmap, and I'll go on to a little bit about the sensor, its operating principle, its specifications, and provide some test data. And then I'll talk a little bit about future developments. So just a little bit about Sentience. So we're an international company headquartered in Columbus, Ohio. We have sales, engineering, and manufacturing everywhere in the region. We have 75 years of experience of developing reliable safety devices for home appliances. So a little bit about the products we do. So they can broadly be divided into two categories, sensing solutions and hermetic solutions. The offering for the HVAC and refrigeration market tend to fall in the sensing side. So we have temperature sensors, pressure sensors, bimetals, and my own area of expertise is the automated controls for appliances. And again, why choose us as a partner? So innovation and product development is at the heart of what we do. We have a broad range of product platform that we can easily customize for everybody's needs. And we have test capabilities all over the world. So we develop reliable, high-quality products that meet all the latest legislation. We're very involved in the standardization process as well. So we sit on trade associations and standards committees. And now on to the kind of the situation with refrigerants. So I think every industry needs to consider how they're going to decarbonize, whether that be electrification for cars, hydrogen for power systems, etc. And where it falls in our industry is the need to kind of reduce our equivalent CO2 tonnage. So for the HFCs that we use in the application. So just what we mean by equivalent CO2 tonnage is each refrigerant is given a kind of a score, which is an index value, which is a multiplication factor compared to CO2 on the amount of infrared radiation that particular refrigerant will kind of absorb and keep in the atmosphere if released. So part of the legislation, there's been two limits defined, the 750 GWP and the 150 GWP. The kind of consequence of this is a lot of commonly used refrigerants face outright bans, which leaves us with the option for A2L or natural refrigerants going forwards. And I think the consequence of the move towards kind of lower GWP refrigerants is they tend to be more highly flammable. There are standards which give us ways in which we can deal with this, and one of those ways is by the use of gas leakage detection sensors. So as a company, we spent 75 years protecting families with our safety devices and safety controls. So it was only natural that we would step into this market, if you like. So the first step in that was to do a technology evaluation of the technology available in the market. We studied all the different technologies, and from our assessments and backed up by AHRT independent assessment, the Nevada nanotechnology was the best in class. So in 2021, we signed a joint development agreement with them to incorporate their technology into our sensor. So phase one design was to incorporate the module. You can see the number 2 over there. And then as we've progressed through the development phase, we've kind of more deeply integrated the solution into our design, which is the phase 2 development, box number 3 there. The certifications we have today, we have the UL certification to UL 60335-2-40, first for R32 and then for R54B. And today we've launched into mass production from our production facility in Delicias, Mexico, with this design. I'll talk a little bit about future developments, which is obviously moving on to A3 gases and adding additional functionality to the current sensor. So this is the sensor itself. It's an extremely slimline design. We believe the most slimline on the market. Today it's dual calibrated for R32 and R454B, but it can be factory calibrated for different gases. It takes a 5 volt DC input voltage, and it has a Modbus output interface. We report the concentration of gas as a percentage of the flammability limit down to 0.1 resolution. It says there we have a response time of 30 seconds to a 25% step change in LFL. We're actually in the process of doing some test work to reduce this to 15 seconds. Well, one of the major advantages of the technology is that it's kind of, you can plug it in, install it in your appliance and forget about it. And the reason for this is it has a proven kind of long lifetime, which we've got some test data to demonstrate. It's immune to poisoning and it needs no calibration. We calibrate it as part of our manufacturing process, and then once in the field, it never needs to be calibrated again. So, and then it's a little bit about the underlying technology. So on there, we have a micro machine membrane, and there's a small hot plate. And what we do, we heat that hot plate up to a known temperature, and the energy required to reach that temperature is dependent on the gas present in the environment. So we do a kind of multi-point test on that at different temperatures to ensure that we can fully extract the signature of the target gas. We also onboard an environmental sensor, and that measures the temperature, relative humidity, and atmospheric pressure. And it can use that to compensate out the kind of signals that you may see from that gas that may be falsely interpreted as a target gas. So, and there's a little bit of test data to support the kind of reliability and performance attributes of the sensor. So across the top, what we do is we expose the sensor to different kind of environmental transients, first into a condensing environment, then a rapid heating environment, and a rapid cooling environment. So, and the kind of what the test results demonstrate is the green lines across the bottom is that under all conditions, we don't see any false positives whatsoever. The graphs on the bottom, they show the kind of the test data we have for the life cycle and reliability of the sensor. So on the one on the left is kind of normal operation. So we've got continuous operation for 5 years. And the net result of that is no drift in the sensor accuracy whatsoever. The graph on the left is actually an accelerated life test. So in normal operation, we run the sensor and sample the atmosphere every 2 seconds. For this test, we accelerated that to 7 times per second, so 14 times its normal life cycle. And the result of that, it works out to be the equivalent of 12 years of operation that we've seen. And again, the result of that is we've seen no sensor failures and no sensor drift across the whole test.
Right. And
so, and the final slide on test data is to do with exposure to kind of foreign chemicals, if you like. So, again, one of the advantages of technology is its immunity to poisoning. One aspect of that is immunity to oversaturation of the target gas, and the second is exposure to non-target gases. So the table on the left shows the list of target gases that we're exposed to. They're exposed to the maximum allowable ppm that you'd ever see in the workplace, and they're exposed for 2 hours. The table on the right shows the chlorinated gases that we tested exposure to. So the graph on the top left, that shows the results of a sample of three of the foreign chemicals, if you like. So what the test is intended to show that over the whole 2 hour kind of duration of the test, the green line at the bottom shows that we didn't see any false positives. And then the two graphs on the bottom, they show the kind of post-exposure performance of the sensor. So on the first graph, it shows that when then exposed to the target gas again, after the exposure to the foreign gas, that we see, again, no degradation in performance in terms of the response time, and the graph on the right shows the same thing, no degradation again, but this time in terms of accuracy of the sensor. So, and then the final slide I've got is obviously that's where we are today. We've developed the A2L sensor for the R54B and R32 gases. So what comes next? What we're currently working on is the sensor for R290. So that needs a higher resolution due to the higher flammability of the gas. We're currently building samples over in our site in the UK at the minute, so they'll be available this year, and we intend to go into production in early 2026. Another program which I'm involved with is I spoke before about adding more functions to the sensor. So the sensor we have today is Modbus, and we're aware that not all systems have a controller which can interface to Modbus. So what we've added is relays to the sensor so that you can directly drive fans or cut off compressors in response to a leakage. So okay. So that's the end. I'm happy to take any questions. I'm happy to talk to anybody afterwards or visit our booth. So, yep.
Commentary, race up. Yeah, is it okay? There you go. Hey.
How does the sensor deal with dirty environments? Is there any problem with dirty environments like dust, oils?
Yeah, that's what you do.
Terrible.
So yeah. So now, so the sensor itself has a filter on to obviously stop water entering into the appliance. It also stops kind of dirt entering into the sensor itself. And obviously, there is a possibility. We do recommend the mounting orientation of sideways so that it prevents dust and dirt from accumulating on top of the sensor. But what we found during testing is you can have quite a high level of kind of blockage of the filter, if you like, or blockage of the detector, and it will still perform correctly. What we've also developed at the minute, which we're in the process of securing a patent for, is a filter blockage detection algorithm. So what that will do, it will actually detect if the filter is blocked and report that as an error, and then inform the kind of user that some maintenance is required.
Yep. Oh, you guys could test. Does it allow water dipping? Dipping. Water exposure. Liquid.
Like I say, the sensor is fitted with a hydrophobic filter, so the enclosure itself is IP54 rated, so that's not for full submersion in water. Yeah, so it's tested to the equivalent of the shower with the IP54 rating. So yeah. Anybody else? Okay. Yep. Thank you very much. Hey. Let's say we're in Hall 4, booth number 130. If anyone would like to visit us.